Hello, Hornets, and welcome. Thank you for joining me today. Today we're going to be taking a look at the pretest for Chapter 3, Number 2. This is for Honors Pre-Calculus, so please, if you do not have that, please take a look at what I have up here, and I will try and give you the opportunity to take a picture of it. Here's 1, 2, and 3. Followed by 4, 5, 6, and 7. Zoom out just a little bit so you can see it all. And going to the second page, the other side, here we have 8, 9, 10, A and B. And then we have 11, 12, 13, 14, and 15. Now, I'm not entirely sure how long this video will be, so I may end up having to break it up into 2 parts, but I'm going to go ahead and start. So the first question asks us to simplify, and we have log base 9 of 27, and we are being asked to convert it into log base 3. So what we need to do is we need to change our base. And the first thing I'm going to do is look at this as 3 squared, 27. And whatever I do here, in order to make it to the appropriate power, so if I wanted to get it into a 3 cubed, I'd have to get rid of the 2 and get it into a 3. So what we had is what's going to be in the denominator. What we want is in the numerator. We want log base 3 to the first, so 1 is in the numerator. What we had was a 2, so 2 goes into the denominator, and we now have 1/2 log base 3 to the first power, and I'm now going to make this 3 cubed. After all, 27 is 3 cubed. That then allows me to bring my power to the front by the expansion of logarithms, and I get 3/2 log base 3 of 3. Now we have a rule that says log base 3 of 3 is 1, leaving me with the answer 3/2. That's number 1, at least 1A. 1B is now asking me to do the same thing, but now we have something that is not going to give us such a nice answer. So we're going to have to take that 2,000, and we need to break it up into prime factorization. That's ultimately what I did here. So I'm going to take the 2,000, I'm going to break off the 2, and it's now times 1,000. 1,000 is the same thing as 10 times 10 times 10. Now let's just make it 10 cubed, shall we? 10 cubed is 1,000. But I know that 10 is 2 times 5. Someone is having a lot of fun with their music. And then 2 times 5, and then 2 times 5. Now you'll notice I have 2 4 times, and I have 5 3 times. This is what I'm looking for so that I can put it inside. I like the 5 cubed to be first, 2 to the 4th to be second, and now I expand. Log base 5 of 5 cubed plus, for the product, log base 5 of 2 to the 4th. Power of 3 moves to the front. Log base 5 of 5, we're going to use a 1. 4 moves to the front, and log base 5 of 2 cannot be changed. So if this goes to a 1, my answer is 3 plus 4, log base 5 of 2. And this is my answer. That's as far as I can go. Going to number 2. Number 2 is asking us to first find the inverse and then figure out which of my choices is valid. So if I'm looking at f of x is equaling negative 3 times 2 to the x minus 1 plus 4. We let x go where the y is, and y goes where x is. and we start solving for x. That means I'm going to go ahead and I'm going to start by subtracting 4, dividing by negative 3, so that I have 2 to the power of y minus 1 by itself. Distributing the negative up to the numerator makes it 4 minus x over 3 to y to the minus 1. And I now need to exponentiate. I'm going to put it into a common log, either log base 10 or log base e, which is our natural log. I'm going to go ahead and I'm going to do natural log. So I have the natural log of 4 minus x divided by 3 equals the natural log of 2 to the power of y minus 1. The power has to move in front. It's at this point that we start to look at what our options are. For example, I have the choice of dividing by the natural log of 2, giving me the natural log of 4 minus x divided by 3 all over the natural log of 2 equals y minus 1. I can therefore have y equal to the natural log of 4 minus x divided by 3 over the natural log of 2 plus 1. Because I can always get a common denominator, I can also make this y equals the natural log of 4 minus x divided by 3 plus the natural log of 2 over the natural log of 2, natural log of 2, which leaves me with y equals the natural log of 4 minus x over 3 plus the natural log of 2 all over the natural log of 2. According to my rules, I can bring this in since I have the natural log. I have a plus here. It can go in as a product. So I have y equals the natural log of 2 times 4 minus x divided by 3 all over the natural log of 2. That then gives me y equals the natural log of 8 minus 2x all over 3 divided by the natural log of 2. Let's now take a look and see if we can find our answers. This one, if you recall, is this one here with the factor removed. So they have simply called it 1 over the natural log of 2 times the natural log of 4 minus x over 3 plus the natural log of 2. And you'll notice that's all they did. They factored out this denominator and they put it in front. So A is a valid equivalent. That's true. When I look at this one, I can see that they've got this right here. And you'll notice that they just brought out the 1 over the natural log of 2 out in the front, just like they did with A. So B is also true. We look and we can see C. C is right here. So C is also true. And that leaves us to look for D or E. That's not true because there's a 6 down here. F is not true because there's a 6 down there. But E is true. So I now have A, B, C, and E are all true. Once again, you're just going to identify which ones are true and put them on the line, and don't stress if you get one of them wrong. Just keep going. Now we're going to number 3. Number 3, find the inverse of the function. So we're now going to unwind it just like we did up above, except instead of looking for an answer, we're just trying to clean it up. So we're going to write 3 natural log 1 over 2 x minus 4 plus 5. I'm going to call it x and put my y there. So I'm subtracting 5, dividing by 3. X minus 5 divided by 3 equals natural log 1/2 y minus 4. This is slightly different from the one we had because before we had it in terms of e to the x, or to a power of some exponential. This is a logarithm, so if I've got a natural log, I'm going to exponentiate. Let's try and make sure I get that right. Exponentiate, making a power out of the left side and making a power out of the right side. That's all exponentiation means, to make an exponent. And I now have e to the x minus 5 divided by 3 is equal to 1/2 y minus 4. I'm going to multiply both sides by 2. And then I'm going to add 4. 2e to the power of x minus 5 divided by 3, the quantity plus 4, is now my inverse function. That's the answer to number 3. It allows me to now move to number 4. Number 4 is where we are taking log base 16 of x at x equals 1/8. Well, first of all, I don't like that 16. I want to make it into a prime number. 2 to the 4th is 16. I don't like 1/8. I'm going to change it into 2 to the minus 3 power. Now I can begin. Starting with, how do I make the 4 into a 1? I want a 1, I have a 4, and now it's a 1. 2 to the minus 3, power moves in front, negative 3/4, log base 2 of 2, which we know according to our rule is 1, and my answer is negative 3/4. That's the answer to number 4. Number 5 says use our properties of logs to take 1/4 log base 27 of 243. And our goal is to try to find the prime factorization, try to clean it up, write it in simplest form, and evaluate it without the calculator. Okay, so I'm going to have to change this because I want base 3. This is 3 cubed. This is 3 to the 5th. Notice the 5 can come out to the front right now. But we still have to change that log base 27 into a base of 3. So what I do to this, I change it here. I want to have a 3 to the 1st. I'm getting rid of the 3. And it's now just a matter of simplifying things out. So these multiply and I have 5/12. This is simply 1, so my answer is 5/12. Number 6, we're working with trying to find the number of creatures with the carrying capacity. We're given a formula, P of t equals. You will be given a formula on Thursday. Just use the formula, plug in the appropriate value, and find out what you get. I'm trying to see if you can use the calculator to get an answer. They tell you t is measured in months, so we're going to be putting in 800 divided by 1 plus 10 e to the minus 0.1656 times 7. We're going to put it into our calculator and see what we get. So I get alpha y equals, for my fraction, 800 over 1 plus 10 e to the power of negative 0.1656 times 7. We hit enter, and we get 193 creatures. So 193 animals are present on the animal preserve. This brings us to number 7. Number 7 says to evaluate the logarithm using the change of base formula. This requires you to know the change of base formula. And if you don't know the change of base formula, you've got one wrong. The change of base formula says to take log base A of B. becomes log base C of B over log base C of A. Notice the old base is in the denominator and the old argument is in the numerator. So here we go. If I see log base 1/4 of 20,389, I'm going to call it log base 10 of 20,389 over log base 10 of 1/4, or the natural log of 20,389 divided by the natural log of 1/4. Either way, you will get the exact same answer. So just go ahead and plug it into your calculator. ln 2389 over ln of 1 divided by 4. Hit enter, and your answer is approximately negative 7.15775. That's our goal. Let's keep moving. Let's try to go to number 8. Number 8 now says approximate your value. So we're going to change this and we're going to expand it, prime factorization, and then we're going to substitute the values of log base B of 3 with that decimal, log base B of 2 with that decimal, and log base B of 5. Now it is entirely possible that you don't use all of them, so you want to go slowly. Here we go, prime factorization. Log base 10, let's make sure, log base B, of 16/15. This is log base B of 2 to the 4th power divided by 3 times 5. We're going to expand that. So this gives me log base B of 2 to the 4th minus log base B of 3 minus log base B of 5. 4 moves to the front, and I'm now ready to start substituting the information that they gave me at the beginning. They told me that log base 2 is approximately 0.3487, and there's a 4 in front of it. Notice I substituted log base B of 2 with that decimal. Then I have minus 0.5527, and then minus 0.8096. We're going to use our calculator now to find these values. So I'm going to go 4 times 0.3487 minus 0.55527 minus 0.8096. Hitting enter will give me the value, and the answer is 0.0325. And that's the answer we're looking at and looking for in number 8. Let's now move to number 9. Number 9 asks us to use our properties in order to expand this fully. Please be aware that we do have the cubed root, which will be a 1/3 power, and we have x to the 4th minus 1, which can be factored into x squared plus 1, x plus 1, x minus 1. So it's important that we factor completely. We have the natural log, we have x over the cubed root, x to the 4th minus 1. This is going to give me the natural log of x minus 1/3 the natural log of x to the 4th minus 1. I'm now going to factor this piece out. 1/3 natural log x squared plus 1, x squared minus 1. And then this gives me natural log of x minus 1/3 natural log x squared plus 1 minus, and I have 1/3 natural log of x squared minus 1. And then this will also factor into x plus 1, x minus 1. And that finishes off our expansion. And that's what we're looking for as our answer. This brings us to number 10. Number 10 is asking us to graph. And we're graphing the natural log of 7 minus 3x. And we have a system. And the second is 2 to the power of negative 4x plus 7. We're going to put both of these into our calculator. And you'll notice I already have done that. So they're both there. Let me zoom in just a little bit so you can see what I'm working with. Now, if I hit zoom 6, we really can't tell very much. We can tell that our intersection, if it's there, is in the first quadrant. But by changing my windows so that I'm only in the first quadrant, I'll be able to see it more clearly. So I'm changing it from 0 to 5, hitting graph, and you'll notice they do not intersect. If they don't intersect, the answer is no solution. And that would be my answer for number 10, no solution. This brings me to number 10b. Now 10b is where we get the long work. So we have 5 to the 4th power. We then have 3 to the 3x minus 2. And it equals 7 to the 5 minus 2x times 2 to the 3rd power. We're going to have to exponentiate on both sides to get it into a common log with which we can then expand. Once we expand it, we'll distribute the natural log to our terms in the parentheses, and we'll move things around. At the end, we will factor out the x and then divide. Here we go. ln 5 to the 4th times 3 to the 3x minus 2 is equal to the natural log of 7 to the 5 minus 2x, times 2 to the 3rd power. When I expand, I get the natural log of 5 to the power of 4 plus the natural log of 3 to the 3x minus 2 equals the natural log of 7 to the 5 minus 2x plus the natural log of 2 to the 3rd. The powers move in front so that I have 4 natural log of 5 plus parenthesis 3x minus 2 to the natural log of 3 equals parenthesis 5 minus 2x to the natural log of 7 plus 3 to the natural log of 2. This is where we have to distribute. So we're going to distribute our natural log of 3 and our natural log of 7. I therefore have 4 natural log of 5 plus 3x natural log of 3 minus 2 natural log of 3 equals 5 natural log of 7 minus 2x natural log of 7 plus 3 natural log of 2. We want our x's to be on one side and non-x's to be on the other. So I'm going to have 3x natural log of 3 here, and I'm going to add to it 2x natural log of 7. It will then equal 5 natural log of 7 plus 3 natural log of 2 minus 4 natural log of 5 plus 2 natural log of 3. We'll factor out the x, leaving us x times 3 natural log of 3 plus 2 natural log of 7. This is what I'm going to divide on the opposite side. 3 natural log of 3 plus 2 natural log of 7. This is the exact answer that we're looking for. That's what we want. This is what x equals. Now, in order to figure out the decimal, we're going to plug this into our calculator. Here we go. So I will have a fraction. And I have 5 natural log of 7 plus 3 natural log of 2 minus 4 natural log of 5 plus 2 natural log of 3. Then denominator 3 natural log of 3 plus 2 natural log of 7. Notice I do have to close the parenthesis in between each. Now when I hit enter, I get 1.05298, and that is my approximate answer. X is approximately 1.05298. Now we do not know which of these two questions I'm going to ask, or whether I ask you to do them both. So please make sure you practice. This then brings us to number 11. Number 11 asks us to find the exact value of the natural log of 3x plus 2 equaling 6. This is an exponentiation problem where I'm going to exponentiate with my e. E to the power of natural log 3x plus 2 has to equal e to the 6th. The natural log and e will cancel, leaving me with 3x plus 2 equals e to the 6th, which means that I have 3x equals e to the 6 minus 2, and I finish by dividing by 3. E to the 6 minus 2 divided by 3. And that's my answer. Number 12 asks us to find a population. In fact, it asks us to figure out what is the value of k that will make the population happen. We are told that the formula is P of t is equal to 122 e to the kt power. We are told in this problem that population t equals 0 is 1990. We're looking at a population of 2,000, which means that I've gone 10 years. I now can say that I'm looking at the population of 10 years is 122 e to the k times 10. But they tell me what that population is, 1,307,000. So I'm going to put that in. 137,000 equals 122 e to the k times 10. I'm going to divide, so I have 137,000 divided by 122 equals e to the 10k power, and I'm going to exponentiate. Now be aware you can get a better number or fraction by simply putting in 137,000 divided by 122, and then hit math, fraction, enter. Notice I get 68500 over 61. That's going to be the simplest form that we can get. And this is now giving me e to the natural log of e to the 10k. The power moves in front, and natural log of e is 1. So this will give me natural log 68500 divided by 61 equals 10k, and therefore 1/10 natural log of 68500 divided by 61 is k. And that's what they're asking for. All right. Now, they do ask us to round it to the 4 decimal places, so I put it into my calculator. And hit enter. And my answer will end up being approximately 0.70237. This leads me to number 13. And in number 13, we are simply asked to identify the x-intercept. Y equals 2 plus log base 3 of x. Well, all y values of x-intercepts is 0, so I'm going to replace my y with a 0. Thank you. I'm going to subtract 2. And then I'm going to exponentiate. 3 to the negative second power equals 3 to the log base 3 of x. Notice when I want to get rid of a log base 3, I have to take it to a power of 3. They will now cancel. 3 to the minus 2 power is equal to x, and 1/9 is x. Number 14. Number 14 and 15 are now our two solving problems. So we're starting off with log base 4 of x plus 4 plus log base 4 of x equals log base 4 of 5. And I need to get them into a single logarithm on both sides. This is one of the reasons why we had to learn how to condense. I'm now going to condense log base 4 of x plus 4 times x to represent that sum. And it equals log base 4 of 5. Now that I have this, I can drop the log base 4 on both sides, and it's the same thing as exponentiating. I then have x times x plus 4 equals 5, and therefore x squared plus 4x is equal to 5. For x squared plus 4x minus 5 equals 0, and I now have x plus 5, x minus 1 equals 0. This gives me two possible x's, x equals negative 5 or x equals a positive 1. But because this is a logarithm, we have to check our domain, Mr. Lamb, not dogma, domain. Domain. And the domain comes from these two logarithms. You'll notice the first one says that x is plus 4 has to be greater than 0, or x is greater than 0. We want the more restrictive. And you'll notice the more restrictive is x is greater than 1. Since x is greater than 1, negative 5 will, let's try that again. X is greater than 0, x equaling 1 is the only possible solution. So the solution is 1. Once again, check your domain before you answer the question. The last problem that we have is finding the exact value of 3e to the 2x minus 8e to the x plus 4. Now, when you're doing this, always start by looking at the middle term, because that's what the dummy variable will be. In this case, e to the x is equal to u. Now rewrite it showing e to the x. Will require you to factor out the 2, that's that power, and then e to the x plus 4. We now put in u. 3u squared minus 8u plus 4 has to equal 0. This gives me 3u minus 2 and u minus 2 when I factor. I end up getting u equaling to 2/3 and u equaling 2. Since my u is e to the x, I have two possible solutions. E to the x is equal to 2/3 or e to the x is equal to 2. When I exponentiate, I get ln of e to the x equals ln of 2/3. ln of e to the x equals ln of 2. That means that x equals ln of 2/3 or ln of 2. And that's the solution that we're looking for. That is the pretest, Hornets. I hope this helped. I will put some additional support practice for solving of our polynomials that have e to the x's in them, so that individuals can have additional support and practice with it. Thank you very much. I hope this helped. Please click like if you liked it, and I hope you have already subscribed. Thank you very much. Take care and be safe, Hornets. And remember, it's easy to be mean, so take the higher road and be nice to everybody. Thank you very much. Cheers.